All right, there are certain lessons where the pre-lesson is just so valuable. So please stop this, watch the pre-lesson, and then you'll understand this a million times better. I'm just going to dive in, assuming you've watched the pre-lesson. So what we have here is a problem asking us to give the 6 trigonometric functions. Remember, there's sine, cosine, tangent, and the reciprocal of sine is cosecant. The reciprocal of cosine is secant. The reciprocal of tangent is cotangent. So really what you need to do is just find these 3 and flip them. But you have to have the reciprocals memorized. So commit those to memory, you guys. It'll be a lot easier for you next year in pre-calc. All right, so this is a 45, 45, 90. And if you remember your rules, which we reviewed in the pre-lesson, we're just going to multiply that by the square root of 2. Now, if you forget that, then you can go a squared plus b squared equals c squared, and you'll get the same thing. But if you remember your 45, 45, 90 rules from geometry, your life will be a lot simpler. This is my opposite side, because this is my reference angle. This is my adjacent side, and this is my hypotenuse. With that in mind, sine is so ka toa, and we'll get to cosecant and stuff underneath there second. What's the opposite side? 4. What's the hypotenuse? 4 square root of 2. I'm going to reduce these 4's and make it 1 over 1 square root of 2. And I got to get that square root of 2 out of there, so I get the square root of 2 over 2. That is sine. Now what I would like for this to have is theta, 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 because really that's your reference angle, okay? So what is the adjacent side? Well, it's 4 over 4 square root of 2. Now if you notice, these are the same. We don't need to reinvent the wheel. We're going to get the same thing, square root of 2 over 2. Now, tangent is opposite over adjacent, which would be 4 over 4, which reduces to 1. So the easiest thing to flip would be tangent. So if I flip 1, I get 1. Now here comes a little trick. I want you to concentrate right here. If I flip sine from here, that's going to tell me what cosecant is real fast. Now, and the same thing, remember, sine is the same thing as cosine in this problem. So if I just flip this, I'm going to figure out what secant is as well. Now, I could flip this. It'd just be a lot more work. And then I go like this, and I get 2 square root of 2 over 2. These cancel. See, I just get square root of 2 anyways. But I'm just showing you a little trick so you can save yourself a little time. All right, now this one's going to be a little bit more involved because it has a spinner. Now I don't like the way this is worded, so I'm going to try to make sense of it. It says give the values of the 6 trigonometric functions. So that means you need a right triangle. And it says for an angle theta. What is that? That is your reference angle. We'll talk about that. In standard position. What does that mean? It means your spinner is going to go like it's here. It means start in standard position. But then you're going to spin it, and see it says the terminal side. That's where it ends. I don't like this phrase, passes through. It should say stops at. So we find this point 6, 8. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. That point is the end point of your spinner. So you hit your spinner up, and it stops right there. Now remember, this is 6. This is 8. We need a right triangle. And I hope you remember in the pre-lesson, you always go from the end of your spinner down to the x-axis. This is my x-axis, this is my y. That's how you always create your right triangle. So there it is. So what we have here, 6, 8, we got to find our hypotenuse, because remember, if we're going to find sine of theta, and by the way, this is my theta, theta is always, 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 in other words, your reference angle is always between your spinner, which is your hypotenuse, and your x-axis. That is an always rule, so don't forget that. That's huge. So I just gave you two always. You always go from the point down to the x to create your triangle, and theta is always found between the spinner and the x-axis. Remember that. So we got to find sine of theta, cosine theta, tangent of theta, and then we'll flip those. Well, we need our hypotenuse. So one student might go a squared plus b squared equals c squared, and that's fine, because that's 36 plus 64 equals c squared. This is 100 equals c squared. Take the square root, and we get 10. Now, I don't know if you guys remember this, but from geometry class, there used to be 3, 4, 5 families. If you just double this, and double this, then we have 6, 8, 10. So if you remembered your families, you could have just went right there and said, hey, I think it's 10. So what is sine? Opposite over hypotenuse. The opposite is the 8. Hypotenuse is 10, so it's 8/10, which reduces to 4/5. Cosine, ca. Whoops, that's an h. So the adjacent side is 6. Hypotenuse is 10. That reduces to 3/5. Tangent, toa. Opposite over adjacent, so it'd be 8/6, which is 4/3. Now it should be really easy to flip these because there's no radicals. So cosecant is always the reciprocal of sine, so that's 5/4. Secant is always the reciprocal of cosine, so that's 5/3. Cotangent is always the reciprocal of tangent. So we're just going to flip that and go 3/4. And that's it for that problem right there. So, all right. So remember the always rules when you're doing 5, 6, 7, 8. And just remember what I pointed out to you. The reference angle is always sandwiched between the spinner and the x-axis. And you always, wherever your spinner lands, in fact, I'll even give you a little nudge. Oh, these are all positives. So these are all going to be very, very similar to what I showed you. All right, you should be ready to go.